Okay, the last example I'm going to show you is another one that's similar to example 5. So again, if example 5 makes sense, you don't need to watch this one. But here's example 5b. Same question here though. What does Descartes' rule of signs tell you about our polynomial function p of x equals negative 2 x to the 5th minus 4x to the 4th plus 3x cubed minus 8x minus 4. All right. So in this one, you might notice that we have an x to the 5th, we have an x to the 4th, we have an x cubed. We don't have an x squared term, but that really doesn't matter. It's just our consecutive coefficients. Okay. So again, there are two parts to Descartes' rule of signs. We have the part about our positive real roots and the part about our negative real roots. The positive part is easier. We'll just count how many sign changes we have. So we start off with a negative 2 as my coefficient. My next coefficient's negative. My next coefficient's positive. That's my first sign change. Then we flip to a negative. We're still negative. Okay, I have two sign changes, which means we have either 2 or 0 positive real roots. Okay, now don't forget that second little part of Descartes' rule of signs, that we either have this many or an even number less. And then negative, to figure out how many negative real roots we have to evaluate p of negative x. So negative 2 times negative x to the 5th minus 4 times negative x to the 4th plus 3 times negative x cubed minus 8 times negative x minus 4. Screw this over just a little bit there. And now we have to simplify. If I have a negative number to the 5th power, it's going to stay negative. So I'd have a negative times the negative out here already. I'd have positive 2 x to the 5th. Negative x to the 4th, this part alone, a negative to an even power is going to become positive. So this is going to be minus 4 still. Minus 4 x to the 4th. Negative to an odd power is going to be negative. Times our positive out here. We have minus 3 x cubed. Negative 8 times negative x is positive 8x minus 4. Let's count up our sign changes now. We start off positive. Then we go to a negative. That's one sign change. We're negative again. We go positive. That's our second sign change. And we finally end with an odd number. So we have 3 sign changes total. Which means we have either 3 or an even number less. We have either 3 or 1 negative real roots. So just like the last one, we're going to put this together to have our, I guess, summary statement. There are either 2 or 0 from right up here. They're either 2 or 0, positive real roots, and either 3 or 1, negative real roots. There we go. Those are all of our theorems about the roots of polynomial equations.